For hyperbola, x squared divided by 2 minus y squared equals 1, with foci f and f prime, and a line passing through f is perpendicular to the x-axis. All right, when the hyperbola and the line intersect at points P and Q, we're going to find the length of line segment PQ. So I did a little graph of it, didn't label too much, but this is what they're talking about. We have a line segment PQ here, and we're going to try to find this length right in here. So this length right here. So let's see what we have. Let's look in our x squared divided by 2 minus y squared equals 1. Now using my formula, our x is the lead, and you look under the x, and your a is going to be the square root of that. So it's the square root of 2. Under the y is 1, so b square root of 1 is just 1. And now let's find our foci. So c squared equals a squared plus b squared. So that's going to be 2 plus 1 equals 3. So basically, if you take the square root of 3, you get plus or minus square root of 3. And your foci is going to be at square root of 3, comma 0, because our center is 0, 0, and negative square root of 3, comma 0. All right. So that's where these two foci are right here, and right here. So now notice that this line here is going through this foci here. All right. So we need to find this point here, and let's look and see what we have. For that, we're going to look at P. So for P, we know that that's going to be this P here. That's going to be some square root of 3, comma y sub 2. And the Q is going to be square root of 3, y sub 2. It's going to be negative 2. And let's call this y sub 1. I should have made this y sub 1. So there's your first y. It's happening somewhere in here. And your second y is happening somewhere in here. All right. So it's going to be negative. All right. Since they're on the hyperbola, these points are on this hyperbola here, this red part. Since they're on there, we can substitute it in and say that for x, we have square root of 3 squared divided by 2 minus y sub 1 squared equals 1. So that's going to give me 3 divided by 2 minus y sub 1 squared equals 1, which gives me y, if you solve for this, you're going to get y sub 1 squared equals 1/2. All right, so that's your square. If you square root both sides, you're going to get your y sub 1 equals plus or minus square root of 2 divided by 2, and I went ahead and rationalized that. All right, so we have y sub 1 equals plus or minus square root of 2 divided by 2. So for point P, that's going to be P, we had square root of 3, and then we're going to use positive square root of 2 divided by 2. And for Q, substitute in the negative part. So that's going to be Q square root of 3, comma, negative square root of 2 divided by 2. All right. So therefore, you just have to find the distance from this part. So this part here, this length here is square root of 2 divided by 2. This length here is square root of 2 divided by 2. So you just add those up. Or you can say the length of PQ, you can just subtract them. So square root of 2 divided by 2 minus negative square root of 2 divided by 2. Basically, you're just adding them up, and this gives you square root of 2. So that's your length of PQ. Thank you. Have a nice day. Bye-bye.